And then when we go over the y-axis, then we're going to have f of x equals negative f of x. Excuse me, f of x, yeah, equals f of negative x. We'll talk about exactly what that looks like. So over the x-axis, it's going to be even. That means it's going to be symmetrical with respect to the y-axis. Same thing here. So even or odd. So just so you understand what even or odd looks like, even is going to be a function that is symmetrical with respect to the y-axis. So we can control the zoom here. It goes crazy when I zoom. Sorry about that. That's an even function, and it's symmetrical with respect to the y-axis. And you see, like second power, fourth power, eighth power, sixth power, they're all going to be symmetrical. And they have matching ends. You see how both ends go up? Whereas an odd power, it's going to be kind of like a snake. That's going to be where you have opposite ends. One goes up, one goes down. That's going to be an odd power. So third power, fifth power, seventh power, hence the name odd function, odd power. Okay, that's a typical idea, and that's going to be symmetrical with respect to the origin. Okay, so origin, that's going to be an odd function symmetry, and even function is going to be y-axis symmetry. All right, so keep that in mind. Now we're going back. So take a look at this one here. It asks us for, oops. One second. So we want to know the following function is horizontally scaled by a factor of 6. So if it's horizontally scaled, that means that it's being stretched or shrunken. So scaled by a factor of 1/6, so that means you're going to have to take the square root of function. That means you're going to be multiple. First of all, if it's horizontal, it's next to the x, right? So it's either going to be x over 6 or it's going to be 6x. And so what they want there is x over 6. Okay, so x over 6. And that's going to be, so again, horizontal scaling means stretch or shrink, so it's a multiplier. And to the 6x or 1 over 6, they should have said horizontally scaled. It should be like compressed, so 1/6. There should be better language there. And translated down to units, so it's going to be -2. That's how you're going to handle that one. All right. Now I'll match the graph. So this is a horizontal shift. Again, so horizontal shift still with values inside, next to the x. So it's going to go to the right 1 and up 2. So to the right 1 and up 2. This looks like a good one here. So the original one, the original function starts out, in case you didn't know, the original function starts out like this, 1 over x. So saying which one of those goes to the right 1, and up 2. Hold on now, hold on. Up 2. So we take that one. Well, right 1, up 2 should be right there. 1, up 2 should be very close there. It's not this one. Okay, so take a little in there. It's not going to be, it's not this one. This one's down, so it can't be that one. So it's either this one or this one. Up run. It's to the right 1, up 2. To the right 1, up 2. So it's going to be up 2. That's the key thing. It's up 2. And this one's up 2 also. So what's the difference between, oh, this one's inverted. So this one's negative. Okay, this one's negative, so this one's wrong. So this one's going to be our answer right there. Okay, you see how the original function looks like this. And this one has it reversed. This one changes it to here. So that would be implied that you had something like y equals negative 1 over x. It's going to shift it if you have a negative there. That's what's happening there. Number 8 has a good summary right here. It tells you that A on the outside. So remember, A and B are multipliers, okay? So that's called scaling. So it either kind of stretches or compresses. That means it doesn't really, it just moves up or down. Its endpoints stay the same, but it just gets skinnier or wider. So a number on the outside, that's your vertical scale. And remember, anything on the inside is horizontal. Anything on the outside is vertical. So multiplier is scaling, and adding is a shift. So therefore, A, okay, and B deal with scaling because it's multiplying. So that is our vertical scaling. That's our horizontal scaling. This is our horizontal shifting, moving sideways. And this is our vertical shifting, moving vertically. So that's a nice little summary right here, all right, for you to have in your notes somewhere, all right? That's really key. So this one's going to be, it's adding, so it's going to be a shift, it's moving sideways, and it's going to be horizontal, it's going to be -3, because remember the formula says x minus, so it's going to move left 3, because that makes that 0. If I put a -3 in there, it makes that 0. Moving on. Now this is an absolute value function, which we're going to study very soon. So anytime you have an absolute value function, it starts out looking like this. Okay, oh, that's pretty terrible. I don't really like these functions. I'm glad I don't have to use them. That's why we're going to take your test on paper. You don't have to worry about it. But the basic absolute value function looks like this. Okay, and that's the one that looks like that to begin with. And then you can see that it's been inverted. And so that makes something's negative, right? Something's negative. And then you could also see that it's moved. So the point from the center at 0 is now moved to, it's now moved here, okay? It's moved to left 2 and up 2. So it's left 2 and up 2, and it's negative, okay? So that's what's happening right there, if you can see that. So left 2 might be x plus 2, and up 2 might be plus 2. So it's kind of like absolute value of that, right? It's absolute value. There you go. All right, this video is a little bit too long. But you can see that you have a value of x over 2. It's going to point out some key points right there. That basically means that that's a horizontal compression of 1/2. That means it's going to kind of get squashed. Okay, this x over 2 right here. Now moving on here. So now when you have 1/2 on the outside, that's vertical, right? So that means its vertical trajectory is going to be squashed, not its horizontal. Okay, so there's a stretching that happens vertically and a stretching that happens horizontally. This is a vertical scaling. Okay, vertical scaling with the 1/2 on the outside. This is a horizontal scaling because it's on the inside. So I want to make sure you're clear on that. So you're either changing the x number or the y number. When I put a negative on the outside, that's going to be put a negative on the outside. F of x and negative f of x. So that's going over the x-axis right here. It's going to change it over the x-axis, and you're going left 2. So left 2 and over the x-axis. Okay, that's what's happening here. Here, you're kind of multiplying everything by 3, so that's a vertical scaling. It's going to get higher faster. Okay, not the number you're putting in, but the number you get out. Okay, so that's going to be a vertical scaling. All right, so you have some fun with those numbers. The square root of x basically looks like this. And then when you flip it over the x-axis, that's like that's negative f of x. Negative f of x is down here. Okay, so that's this one here. And this one is going over the y-axis, so that's like an even function there. So that's going to be f of negative x. F of negative x, okay? And right here, okay, so f of negative x. Take a look there. So these are a lot of problems for you guys to practice. So anything, again, inside the parentheses has to do with horizontal, outside has to do with vertical. Numbers over here, that's going to be down 3. This means, so f of x, this means we're going over the y-axis right here, okay? This one's we're moving left 2 and then down 3, say, so it's left 2, down 3. Move those points accordingly. That's how you get better at them. There's no way to do them than to actually do, no way to get better at them than to actually do them. All right, so I'll go into the next section soon.